Okay, I'm recording. So I just want to say that, or ask, did everyone maybe go through the links that we have been sending regarding the work so far, that YouTube links? Did everyone go through that? Okay, hopefully you did. Let's begin. So the first question is actually a big question. Is no one gonna say anything? I can begin?
Yes, sir, you can.
Okay. Hopefully I have enough space. Okay, so x minus 1, x plus 1 minus 2x minus 1, 3 minus x plus 2x squared minus 7x, 17. Okay, so I don't know if everyone or anyone knows this, but when you get a question like this, there's always a hint inside here somewhere. And the hint is usually here at the bottom in these ones. Not normally the one you must factorize, but it's normally from these one, like the first or second term, or both even. So x plus 1 and the 3 minus x. But we don't want the 3 minus x, so we're going to have to do something with the sign here to change it. So, what do? We say x minus 1, x plus 1, plus 2x minus 1 over x minus 3. You just swap both signs of both numbers, and then you change the sign of the whole fraction. Okay, then when we look at this top one, the numerator, when you look at the numerator, then you see that we can't factorize this actually, because for me personally, when there's a negative and a negative, maybe and uneven number, it's difficult to factorize, and normally we can't. So normally we just leave it as it is, and if we look at the bottom one, we can definitely factorize the bottom one. 2x squared minus 7x minus 17. We leave it as it is. So x squared minus 2x minus 3 is going to factorize like this. We're going to say 3 and a 1, and it's a negative 3 and a positive 1. Just join a few people. Okay, so
sorry, sir.
yes.
The bottom one is not different from the top one, but you could factorize the bottom one. The bottom then does have a negative sign in front of it.
Yeah, you see, no? For me, it's the unevenness. The unevenness. If you try and factorize this, you can't do it with this method. Then you must use the method of that big factorizing formula, minus b plus minus b squared.
Yeah, yes, I see.
Then you will get like a fraction number, decimals, and for this type of equation, you don't want that. You want whole numbers. Okay. So what I wanted to see or notice is that Remember that hint I spoke of at x plus 1, there's an x plus 1 there. There's also an x plus 1 there. And we change that to give us x minus 3. And here we have x minus 3. So in the equations, they always give us a small hint that we're not always aware of, but this is how we know we're on the right track. So what we do now is, because we know a few like terms, let's say that, we have a few like terms, we're going to use x minus 3 and x plus 1 as the denominator. We're going to put all this together now. We're going to add everything. So we're going to say x minus 3, x plus 1. So this x minus 1, this fraction doesn't have a x minus 3. So we put a x minus 3 there, plus this fraction doesn't have a x plus 1. So we say 2x minus 1, x plus 1. Multiply like that. Then this fraction we kept the same, and it has both numerators. So, denominators. So we write it as it is. Now we do is we multiply out the brackets, multiply out everything, simplifying basically. We are simplifying. So we get the x squared minus 3x minus x plus 3. So it's x squared minus 3x minus x plus 3. For this one over here, it's 2x squared plus 2x minus x minus 1. That minus 1 over there. And then we still have this as it is. What we do now is we simplify this. And okay, let's do it quickly. So here's the x squared. Okay, first we get all the like terms together. Here's the x squared, here's the x squared, that's the x squared. This is x values, then a number, and a number. So x squared plus 2x squared plus 2x squared is a 5x squared. 5x squared. So minus 3, 4, 2, minus 3, minus 4, minus 2, minus 3, 7, minus 3 and minus 7 is minus 10x, 3, 17, 18, minus 15, over like that. So when we look at this, we must see that there is a common factor of 5. So we take out the common factor, x squared minus 2x minus 3, x minus 3, x plus 1. So we must now factorize this x plus x minus 2, x minus 3. So if you look at this one here, this is this one over here. If you can see that. So it's going to factorize the same as our denominator. So we're going to have x minus 3, x plus 1, x minus 3, x plus 1. Then that will cancel with that one. This will cancel with that one. Then we're going to be left with a 5 as our answer. This is a lot for the first question, but yeah, this is the answer. Our answer is 5.
Yeah. I got -4.
Yo.
-4.
You see?
Because I'm.
Yeah. You somewhere here you messed up. Somewhere
No,
there.
I did not went through that way because the top one and the bottom one I could not factorize them. So what I did, the x minus 1 and minus 2x minus 1. I did x minus 1 times 3 minus x and vice versa, and then the two of them, the bottom one gave the same denominator with the other one, which I play around with the minus, and they came to the same sign, which was x squared minus 2x minus 3. And the top one I just added the bottom of them, which I was sitting with the 5x squared minus 8x minus 15 over x squared minus 2x minus 3, which I then simplify again.
Yeah.
And came back to -4. So
yeah, you were very close. Very close.
Yeah, I was just so close. I don't know if I think maybe I was,
yeah, you were very close. It sounded like you were very close. You just got an 8 there. You had an 8.
Yeah, yes, I got the 8 there, yes.
Yeah,
and
you were very
15,
close.
Yes, I got the 15. That's why when you say 5x squared, I was like, yes, I'm here. And then you say minus, that was like, oh. Yeah. And I also got the 15. I don't know if there's somewhere maybe I will just go through it again. If I maybe mess up my numbers, I'll just look at it out.
Yes, please do that. You see, one thing about this, like you need to look at the hints. There is always a small hint like that over there. Over there, that's a hint.
Yeah.
That's a hint for factorizing. Maybe it's always gonna be the denominator that like the hint is for, because it's very important to get this one first. This simplifying should be very easy.
Yes, on that level where you are at, it's very easy now. But to get there, it's not that easy.
Yes, that's why you just follow the jumping. First x times x. Yeah. Hello. Okay. Yes. But just if you get confused with multiplying out, just always throw that jumping for yourself. But okay. So is everybody okay with this question? Then we can move on.
Yes, sir, we can move on.
Okay. So this next question is.
Can you just give me 1 minute, 2 minutes?
What do you want to do?
I just hope so. Yeah, I'm almost done though.
Okay.
So, can we also mute the other person that is unmuted?
Yes, guys, can everyone please mute ne? Until you have a question, you can raise your hand or you can just say something. But while we're explaining, can we have everyone muted, please?
You may continue, sir. Thank you so much.
Okay. No problem. So, this next one is showing 2y over x minus 2y over z over 6 over x minus 6 over z. Okay. Yeah, when you see this, you see it as a lot. But how we're gonna do this is we're gonna deal with it, that PC, that PC, then we're gonna have this PC. So we can simplify this one. So we know that we're gonna have a denominator of x and z. So it's gonna be x and z. So this 2y in this fraction doesn't have a z. So we're gonna say 2y z minus this 2y doesn't have a x in this fraction that we're gonna put together. So it's gonna be 2yx. Does everybody understand that when you're adding and subtracting fractions together, you make the denominators the same? Okay, so we know that this big line over here means divide. So we keep it like that, and we say the same thing as we did here. We're gonna do now for the bottom. So we're gonna say 6z over xz minus 6x equals. So we can simplify this over here, and we're gonna say 2y z minus x over x z. So when you divide a fraction like this, we do what is called the reciprocal, and then we change this sign into a timesing sign, multiplication, and we're gonna have xz over 6. We can also factorize this z minus x like that. So the first thing you must be able to see is that we can now cancel this xz with that xz, and this z minus x with that z minus x. Then we have left with a 2y over 6. 2y over 6. And then this can simplify into y over 3. All you have to do is you do this PC on its own, and then this PC on its own. You don't do it all in one big step. You can break it up like this, because it's saying the same thing. It's still division there, and it's still division over here. Does everybody understand?
Yeah, that's perfect. Right, so write it down.
Okay, no problem. Just let me know when you're finished.
I have a question.
Yes.
You see there when you change the sign to multiplication, I saw that you did the inverse, which is I'm fine with that. But now when you take out okay, that was xz on the numerator, denominator. Now it's z minus x. Then is the xz and x minus z the same? Oh no, I see. Sorry.
Yeah.
I see.
Yeah.
That comes the other side. Okay.
Yes. If it was like that though, right? If it was like you are saying, then what you are saying is this, ne? If it was a 6x minus 6z. If it was like that, what you have to do is you would take out the negative like this to be 6x plus 6z. But then you must swap signs around like this. So you can have your z as positive and your x as negative, just to match on the other side. Because your goal here is to always get where you can cross out and simplify in this manner. If you see that maybe you swap the sign and it's x minus z and here's a z minus x, then you just go back and double check, am I sure about this, or should I change the sign now?
Noted with thanks.
Of course. Can we move on? Is everybody finished? We can move on. So, next one is saying, say 8 square root 8 square root 32 square root 18 over 2 square root 2. Okay, so again we have a small hint, and our hint is this over here, a square root 2. So basically we must find the multiples of 2 that will go into this 18, that 32, and that 8. And it's very simple. It's very, very simple. We're going to say 4 times 2 for that 8 plus 16 times 2 minus 9 times 2 over 2 square root 2. Come on, my pen is dying. Then what we do is we take this number that's in front. Where is my green pen? So we take this. Now we get this one out, that one out. We're going to leave the 2 behind, and then what we're going to do is to get this 4 out, we're going to say square root 4 is 2. And then we are left with a 2 there, plus square root 16 is a 4, and we are left with a 2 there because we're leaving the 2 behind. And then square root 9 is a 3, and we're left with a 2 over there. And we have here our 2 still. So how we deal with this now is we're going to say this 2 plus this 4 minus this 3. And this is 6 minus 3 is 3, and left with a 2 over 2, like that. Then this will cancel with that one. Left with 3 over 2. Our final answer.
Sorry, sir.
Yes.
Can you maybe go back to the before the 3, the big one? With the green, yes, please.
Okay. So we can't do anything with this. And also this is like, this is saying, this is what this is saying. This is saying basically it is a 2x plus a 4x minus a 3x. This is all what it is. Then we're gonna have a 2x like that. It's the same this thing. So 2 plus 4x is a 6x minus 3x is 3x, 2x. In maths, you see this 2 is just there to confuse a little bit, man. It's just there to confuse you. But it's the same thing as this x. Exact same thing. Means the exact same thing. Nothing different about it. Does that maybe lighten things up?
Yes, sir. So can sir just go back to this first one? Why did we write the 2 plus 4 plus minus 3 there on top?
Oh, I was just showing you how we're adding them.
Oh,
How we
okay.
adding
Now
them.
it was 6 minus 3, then we got 3.
You see, this 2 plus that 4 is 6 minus 3. Yeah, like that.
Okay, amazing. Thank you, sir.
Of course. This
Hello,
2,
sorry, sir.
yes.
Can you please just assist on the 1, 2, 3 on the 3 step there by the when you say 3 square root of 2 divide by 2 square root of 2. How did we get there? On the third one, 1, 2, 3.
This one over here.
No, below.
This one here.
Yes, how did we get 3 square root of 2 and 2 divide by 2 square root of 2? How did we get on that
Yes.
stage?
On that stage. Okay. So again, yeah. We must add this now. You see that you can only add the numerator together because this 2 is a 2 there and it's a 2 there and it's a 2 there. That is why we can add them together. It's like terms. It's like terms. You can only add like terms together. So it's the same thing as saying 2x plus 4x plus 3x. So 2x plus 4x minus 3x is a 3x. But let's do it like this. This 2 plus this 4 minus that 3 gives us 3. And then we're left with a square root 2. Our denominator is the same. We can't do anything with our denominator yet. So we just write it. After we write it like this, then we see what can we do further. What we can do is we can cancel that square root 2 on top and the square root 2 at the bottom. And we're left with a 3 over 2. That is how we have a 3 here. And this 2 over here.
Okay, I got it. Okay, thank you, sir. Now I got it.
Okay. That 2 is just to confuse you. But you must look at it as like terms. It's the same as an x. Exactly the same. As you can see here, if we work it the same way, we get the same answer. Nothing different. Nothing different. Can we move on? Okay. So, the next one, it's kind of the same. It's kind of the same. So, 3 and 20. 3 and 20. 2 and 45. 80. And then 125. Okay. So, firstly, whenever you look at equations from question 1 to 4, or yeah, question 1 to 4, always keep your eyes open. Because remember I said for this question here, our hint basically, our hint was this square root 2 over here, right? It's basically like the multiple for these ones, the lowest common multiple. So we know that we're going to work with a square root 2 throughout the whole fraction and the whole equation. Must look out for that. Because if you get that wrong, you can't work. Anything you work from there is incorrect. So here, our hint is what? Our square root 5. Our square root 5 is our hint now. So we know that we're going to work with a square root 5 throughout the whole equation, and it's going to be left behind, like, as we are working. It's going to be left behind. And I'm going to show you how it's going to be left behind. So we have a 3. We leave the first numbers and we deal with what inside the house, inside the square root. So we have a 4 times 5 is a 20 plus 2. 9 times 5 is a 45 minus let's not say, okay, 5 is 36 times 5 is our 180, and then we leave that as is. And then 25 times 5 is about 125. Always you must break it up like this, always. And then what we do is the same as the last question we did. We're gonna say square root 4 is a 2 times 3 is a 6. It's a 6. But let me write it like this rather. Let me do it like this rather. Okay, so it's a 3 times square root 2. 3 times square root 4 is a 2, and then we're left with a 5. This 2 times square root 9 is times 3, and then we're left with a 5. Minus square root 36 is a 6, and we're left with a 5, and then we are left with that also over there. So that 25, square root 25 is a 5, and then we're left with a 5. Is everybody okay with that? Or we must...
Sorry, can you please just repeat this again?
Yes. So remember I said that the hint, this is our hint over here, right? That's our hint. That's our hint. So our hint will always be left behind. So that's going to be left behind, that's left behind, that's left behind, and this is going to stay the same. So all we must do is to leave our square root 5 behind and take out this number we are multiplying with. And the only way we can do that is by square rooting that number, because this is a square root. You square root this number, then you multiply that number with the front here. You square root a 9, multiply with a 2. You square root 36, you multiply with a 1. There's a 1 there actually. Does that make sense? You square root this number. Square root 4 is a 2. Multiply the front number. 3. Square root 9 is a 3. Multiply this front number. That 2 over there. Square root 36 is a 6. Multiply that 1 that's not there, but it's there. Does that make sense? Yes, no, maybe?
Yes, sir.
Of course, lovely stuff. Just know that you're going to keep behind the 5. And as you can see, we are left with the 5 alone. That's all we want to do. Because what are we going to do now? We're going to simplify. We're going to say that 3 times 2 is a 6 square root 5 plus 6 square root 5 minus 6 square root 5 plus a square root 5 over 5 square root 5. So this is the same thing. Let's make it nice and easy for us. That will cancel with that. Can we see that? Positive 6 square root 5 minus 6 square root 5 will cancel each other. Then we are left with, let me write this again. This is a 6 and that's a 1. So 6, this like term plus this like term is a 6 plus 1. So it's a 7 square root 5. Because there's a small 1 there, but we just don't write it. But there is a 1 there. I've seen many people forget that 1 that is actually there. Like here isn't a 1, but we know that's a 1 that is there. Even there's a 1 there. It's imaginary, but it is there. Over 5 square root 5. Our denominator does not move from there. And again, we can cancel. And then we're left with a 7 over 5 as our final answer. Are we together? Hopefully we are together.
Yes, we are.
Lovely stuff. You will just see that there is like terms. Before it was a square root 2, now it's up a square root 5. All we must do is leave behind our hint, square root the number we're multiplying with, and then just do it like this. Find the hint. So you find the hint, and then how can we say this? Simplify square root with hint. So you're going to simplify the square root, but with your hint included in there, because it has to be inside there. So you must simplify with respect to your hint that you have. Then you square root that number, and then multiply with outside, maybe. If there is an outside number, like that 3 that's there, that 2, or this 1. Then number 4 is, let's say, add or subtract the like terms. Add or subtract the like terms, because these are all like terms, and I hope you're going to see it as like terms. If you get a question like this, most definitely you'll get a question like this. Then our 5 is simplify, because by here you should be finished. You should be finished with your, you should be here by then, or here actually, you should be done. Okay, can we carry on? Don Jones, you have a question?
No, that was a mistake, sorry.
Okay. So, the next one. to factorize. So factorize 4p minus q squared plus 5p minus q minus 6. When you see this, don't worry about the letters, because we have a thing called the K method. We have the K method, and the K method says we can let K equal P minus Q. I hope everybody knows what the K method is. So then we have 4k squared plus 5k minus 6. Then to factorize this one, you can have a 4k and a k. When we multiply, the back numbers must always give us this one over here. So it's a 2 and a 3 and so negative 3 and a positive 2. When you factorize this, I did make a video on factorizing, and I did send it. Please take a look at that video. It's like it's foundation factorizing. So take a look at that. It is in a group. Make a time to go through the example that is there, because I did quite a few. Then we must just simplify this, okay? And we're gonna say 4p minus q minus 3 p minus q plus 2. It's that simple. Very straightforward. You chop and change from p minus q to k. You factorize with the k, and then when you're finished factorizing, you just replace the k with a p minus q, whatever you substituted in there. Just a reminder that when the teams kick you off, just join back again. So the recording will carry on as normal. You'll kick me also off, but just rejoin again, please. Okay. Everybody okay with this one?
When do you know when to use the K method?
When you get the thing that looks like this. When you get letters like that, because normally, right, we get a 4x squared plus 5x minus 6. All the K method is saying is, let's simplify p minus q with the x squared.
Oh, so just make, instead of 2 letters, 1 letter.
Yes. Because you can factorize without doing the K method. You will just write a lot extra, and you might, all of the writing you could, maybe miss a sign, switch a sign, forget a sign. So K method just to simplify, so we can, because otherwise we would have put a PQ there, a PQ there, PQ here, PQ there. This is just a bit simpler for us.
Okay.
You do K method also in a number of other equations, but we will get to that. Everybody okay? This next one is the factor and remainder theorem. So we have f of x equals x cubed x squared plus 11x.
Excuse me, can you please go back? I was still writing.
Right.
So do we leave leave our answer as is there, as also as it right now?
Yes, you can. Because you can't like simplify this any further. I mean, you can multiply out everything. 4 times p, 4 times minus q, minus 3, p minus q plus 2, but then you can't do anything anyway. So we might as well leave it like this. Have you guys been working? I know the group has been a bit too quiet, but there is videos. It is available. Tutorial that was sent. Have everybody been working by themselves from the videos?
Sorry, sir. I'll just join the group today because
Okay.
I didn't realize that I was not added on the group. So I'm gonna ask you to please share the videos of
Yes.
the week so that I can go through it tonight,
Yes,
if
of course.
possible.
Yes, of course. No problem.
Okay, thank you, sir.
Okay. Does everybody know when the test one is?
They moved it 7 days, so it's on the 19th.
Of this month, right?
Yeah, which is not a lot of time.
Yes, but very possible. You see, you have 4 chapters, right? 4 chapters, and those chapters, good chapters. That is still decent. The videos I sent in the groups, right? I will resend it again. Watch those videos. I will try to avail myself to you guys for this next week coming. Work hard. In the evening, take 30 minutes. Just do something, you know? Do an example. Watch a video, do an example while it's playing. But don't wait till the weekend. I know some of you guys working and it's tough, you get home, you're tired. I know that struggle. That struggle is hectic, it's real. But make that effort and I will avail myself to you guys for this week.
No, I think that's what most of us do. Like, I literally, obviously I work, so I get home, eat, shower, and then I'll watch videos and do the activities. I think I go to bed at literally like 1, 2 in the morning.
Wow.
Ever since this has started, because I haven't done maths for 12 years now. I've left school and I've had to redo it. So, like, to re-figure this out, and obviously when you guys weren't in the class, it's not so easy to figure it out if you forget everything that's needing to be done.
Yeah.
So now that you guys are here, I think it will help a lot more that we can actually have the class.
Yes. I will try my best to it depends on getting resources and like a visualizer. This thing I'm using to record right now. Getting it is a problem, but I will try to get one in the week. So maybe a session, maybe Friday evening, Saturday evening. We can talk again. Just to get more revision. That's it, revision. And explaining more. Practice, more practice, just more practice. Usually, I'm not encouraging this behavior, but normally, like, there's asked for a scope, right? Like, people ask for a scope. Now, I'm not saying to now ask for a scope for your test one, but most likely, the tutorial that was sent to you and given to you is your test. So, the tutorial, work through that one like it is the test. Like, don't only practice this, practice other examples of the work, but also pay attention to this. Spend spend time again on this test, like maybe redo it the weekend or in the week, work on it. Because it's a big hint for your test. Normally, I'm gonna say normally. I'm not gonna say for sure anything. Can we move on, guys? Can we move on? Okay. The factor theorem is it's very like trial and error. So we are given this, and we must find what would be a factor of this. Basically, something that will factorize with this equation to give us 0. That's all what it is saying. And normally we start by, like, it's fault finding. If you do electrical work or any work where you must find a mistake, you fault find, and then we start with a simple number as -1. So -1, then we replace a -1 with all the x values that we have here. -1 is 3 plus 6, -1 squared plus 11 plus 6. So if you put this on your calculator, it will give us a 0. There used to be a method to put this in a calculator to actually find what would give you. Let me quickly do that. X cubed plus 6 x squared plus 11 x plus 6. Start at -5, end at 5, step in 1. X is -1. Okay. So I will share a video on this, right? Let me do it again. So you get your calculator. Then you type in this equation here on top, the given equation. You type it in, you say alpha x, you say mode table 3, then you're given this. I think everybody should know about this. There's like a shortcut basically. So x cubed plus 6 x squared plus 11 x plus 6 equals. So the start is saying, it's basically, this is a graph, right? So this is saying our graph will start at maybe a -5, just for a range, to end at 5. Step in 1. So this is saying, wherever this f of x is 0, that x value is this x value over here. Basically the value that is inputted here. So when we factorize cubic functions, there's always like 3 factors that go together, even more sometimes. So here we see where f of x is 0, x is -3, -2, -1. That means that if we put -3 here into this x values, should get 0. If we put a -2 there in all of this, we should get 0 again. Then here we see we have -1, and we chose -1, and it gave us a 0. And yeah, that's all. So let's check this. If you put this in a calculator, you will get 0. So that's on your own. You can do that, but you will get your 0. Then how do we write it? We say if x equals -1, then we say x equal, or no, x plus 1 is a factor. That's only really right. But this is a shortcut. Instead of putting any random numbers and maybe you choose positive 1, then you must work up and down. Calculate it quickly. Fast and quick. It gives you all the factors even. But you only need one. Only need one. I could share on the video perhaps regarding this on the calculator now. It's like a shortcut. It's a shortcut.
Sorry, sir.
Yes.
I could not see properly. After the fx, what did you type on the calculator to have those answers?
Okay, let's start again.
Because
Let's start again, eh?
it's quite a little bit far from the camera, so I can't see it properly.
From the camera. Eh?
Yeah, I think it's better.
Can you see it there?
Can you just go a little bit down, please? I think it's a bit better.
Okay,
I
now,
have
take your calculator in your hand, eh? Everybody now, eh? Everybody that doesn't know this, put your calculator in your hand. Then you say, you press mode. Press mode.
I did that one.
Then you press table number 3. Do you have f of x now on your screen, eh?
Yes, I do.
Then you press alpha x.
Alpha.
Yeah, they kicked me out. They kicked me out. They said I was talking too much. We can get back to it now. I'll just give a few minutes for everyone to join back again. I think they will kick you guys also off, but then just join again, please. Let us just wait. Does everyone understand the calculator so far? The calculator?
Sorry, sir.
Yeah.
Sorry, sir. I was cut off. The meeting just was interrupted.
Yes, no problem. No problem. No problem. Do you still have your x to the power of 3 there?
Yes, I do. But I can't see I can't see the screen now. Can't see like.
Yo, just try and look. Can you see it now? Can you see it now?
Not yet. Nothing, sir.
So I can't see anybody else.
Oh no, I see what happened. My bad, guys. My bad. There we go. Like now, ne?
Yeah.
Yeah, technology is
That is coming.
So yeah.
Can sir maybe take away the x?
Sorry?
Yes, so the x now.
You wanna see where to get it? You wanna see where to get it from?
Yes.
Okay. Do you see on your calculator? On your calculator, you have a thing called shift, right? Shift and alpha.
Yes.
Alpha is for, you see it's like a pink color. I don't know what your color is, but mine is pink.
Yeah, mine is the same.
It's pink, ne? And then you see these letters, that's the same color. You see the letters, that's the same color? And the shift is now, my shift is yellow, and all that's yellow will go with it. So if I press shift, if I press alpha, and maybe I want x because I'm working with x here. I press x, it will give me an x. Can you see? If I press x, it will give me an x. If I press y, it will give me a y. If I press alpha and m, it will give me an m. That's how you get your letters. You understand?
Can you please repeat again, sir?
Okay. On your calculator, you have a shift and an alpha. A shift and an alpha, né? Let me do it off over. You have a shift and an alpha, okay? Shift is yellow. All that is yellow on your calculator. If you press shift, you will get it. How can I explain? This button has two functions. The fraction is on top in white and the yellow one. That is two functions. But to get the second function of this button, I must press shift and that button. Do you see how that block and this fraction is the yellow one? Do you see that? And then the white one is just like that. That's the white one. But the yellow one is this, that block in front. You understand what I mean? Like there's many functions of a few buttons that's in your calculator, and the shift and alpha just like gives you access to that. So alpha, X, that's how you get your letters. So the shift button, anything that corresponds to that color on your calculator will work with that, will unlock that button or that fraction or that symbol. Let's say symbol. Does it make sense? Yo, this isn't maths, guys, ne? This isn't maths. You must take time to play the calculator, man. So, how to do this for the hint, right? You say mode.
Yeah, got you, sir.
Okay.
Sorry, sir.
Yes.
Yeah, but the sign of f of x. I mean, you make -1. But why plus 1 must be our answer?
So
because you shift the sign from minus to plus to the other side.
Yes, when you take this negative to that side, you get positive 1, right? And why I do that, why we do that in maths is because you can say x equal minus 1 as a factor, but it's not nice to say all that, man. You just want to say x plus 1 is a factor. This is just a nicer way of writing it. And also, this is the factor and remainder theorem. This is the factor and remainder theorem. So, what does this tell us? This is the factor and remainder theorem. Yeah, I lost my train of thought now. But we're not done yet. This is just okay. Yes. This is factor and remainder theorem. There's a few questions within factor and remainder theorem as a topic where they give you a factor in this form. So this is like the standard form to put your factors in. So you must do it like this. Okay? I will show you why also. Because when you factorize your trinomials, right? Your x squared plus your bx plus your c. When you factorize, you put it in brackets like this to show that you're factorizing, and then that brackets is a factor. That's why you write it like this. Does this make sense? So now I wanna show you something, right? Regarding this calculator and this hint. So let's do this together. You say mode, table number 3, f of x we have now. Now we're gonna put this equation in a calculator. We're gonna say alpha x cubed plus 6 alpha x squared plus 11 alpha x plus 6 equals. start at the range. This is a, if you understand what a function is on a graph, and a graph has, like, a range, that Cartesian plane with the arrows, the range. We don't want a big range because we want to work in a small little area. So it's 5 minus 5, and we end at a 5, we step in 1. So as we can see again, wherever f of x is a 0, whatever is opposite corresponding x value, that number will become a factor. So x equals -3, x equals -2, x equals -1. I want you to remember this. So let us move on a little bit. So if you can see, I want you to see that this x equals -1 is this over here. So this is x plus 1, and then we should know that this is going to become x plus 3 and x plus 2. But we have to prove this. You see, the calculator gave us this answers. It gave us this factors. But we need to prove it mathematically using the factor and remainder theorem. This is just to check your answer. So how do we do this using the factor and remainder theorem? We use the factor that we got as our trial and error, our troubleshooting. So we write down our given equation. It is x3 plus 6x squared plus 11x plus 6. Does anybody know how to do this equation? To divide with your factor, it's a very big thing in your factor and remainder theorem. So
yeah, you need to put x squared on top.
Yes, but why?
Because you take your x on the outside and divide it by the x cubed on the inside.
Yes. So x squared. Then we say x squared times x is x cubed. X squared times 1 is x squared. And then we subtract. This is like long division. If anyone knows long division from primary school, high school, this is long division basically. So x cubed minus x cubed is nothing. 6x squared minus x squared is 5x squared. Then we bring down the next number, 11x. So now we look at this 5. How I see it, right, is I say x divided by 5x squared gives me a 5x. Always, whatever you multiply from the top in to your factor will always cancel this front number. If it doesn't cancel, you know you did something wrong. Maybe with your subtracting here or your addition here, whatever the sign is, then you know you messed up, because this times this must give you something to cancel with whatever you have on top or just above that one. Always will cancel, always. So 5x times x is a 5x squared. 5x times 1 is a 5. Then again we minus 5x squared minus 5x is nothing. 11 minus 5x is a 6x. Again we bring down the next number and the sign. So 6x divided by x is a positive 6. Then working backwards, 6 times x is 6x. 6 times 1 is 6. We subtract, then 6x minus 6x is nothing. 6 minus 6 is also nothing. So what do we do with this now? What we have is f of x equals x plus 1. We get our x plus 1 from our factor over there, our factor here, and then this is also our factor. This is our factors, but we just have to simplify and factorize this to get it. So x squared plus 5x plus 6. So x plus 1. Now we must factorize this over here. We have x there and x there. So the back you must multiply to get the same, and when you add those numbers, you must get that number. So it's a 3 and a 2, and then the sign is the same. And that's your final answer. Determine the factors. So, what is cool about this? What is cool about this? X plus 1. There's our x plus 1. X plus 3. There's our x plus 3. X plus 2. There's our x plus 2. So, calculator, it is just to check. Is what I did here correct? Yes, it is. Yes, it is. Sometimes, sometimes you maybe choose a 3 here when you're troubleshooting or fault finding, but you will still get the same answer. You will get these two as your factors there, but these 3, as they are sitting here, is your only factors you will get for your cubic function that you're given. I'm now taking my time to explain this, but like they go together, man. They go together. Your factor divided by your given equation will give you your new factors. Will give you your new factors. This is your new factors here. Is everybody okay?
So every time you get a f of x equation, you're going to always find the first factor and then use the factor in the equation to find your next possible factors. Okay.
Yes, you divide with the factor you get.
Yeah.
With your equation to get your new equation to factorize and simplify to get your new ones.
Yeah, so I'm just saying every time you get an f of x equation, this is what you'll end up doing.
Yes. Always, okay. Always. That's one thing about these questions, like you do get a few different ones, but they are few. Maybe you get 4 different types of factor and remainder theorem questions, but the way you answer them will be more or less quite the same. So the more examples you do in different variety, the better, much better you will be. You'll be more comfortable in the questions you get and the way you answer them and the way you attack them, because they each, like, they have their own steps.
They won't deduct marks if you use a different method to the long division, right?
Yes, they will. They will. You see, a question like this, right? And this is very important, very important. But I will get to that in the next, as we continue this. If they say use the factor and remainder theorem to determine the factors, to determine the factors of whatever, né? If you use something else, like you just use this, the hint, right, for the calculator, in the test, maybe, I'm not gonna say you will get a mark, but exam, you'll get 0, you will not get that mark. You have to use the method that they ask you. This is the same for completing the square. When you complete the square, né, you can use this formula. You can use this formula, right? You will get the exact same answers, the same as with this here. You will get the same answer. But they want to see the method they are asking for. If you don't do that, you will not get your mark. Maybe you get 1 mark in the test, right? Maybe, if you're lucky. But exam, you'll get 0. Straight. They see.
So even if you had to use the short method, would you still? But
Yes.
does it obviously, if you look at the mark given, if it's say out of 7, you should know it's long method. If it's only like out of 3 or 5, then you could use the shorter method.
I'm not gonna say yes or no to that, but I will say this. Read your question. They will say use, or they will say by completing the square, then you know I'm gonna complete the square using the completing the square method. If they say
Okay.
yes, use factor theorem, you're gonna use the factor theorem only. Of course, mathematics, you have many other methods, but just do what they ask. Yeah.
So what I was elaborating on, I was gonna use they're gonna say use the factor theorem, and then they will probably give you x plus 1, or you will have to find out what will make the sum equal 0. But after that, I'm not comfortable using the long division method, so I use synthetic division, and it's much shorter than the long division. So I'm asking if they will deduct points off of me using that method besides that.
Synthetic division.
I do get x plus 3 and x plus 2.
That's lovely stuff. You know, that's mathematics. That's mathematics. Let me get back to you on that. But personally, I would say, also, I hear what you were saying. You're not comfortable with this method. I understand completely. Why not do a few examples of just maybe you get a few of those cubic functions, do a few division, mate. Do a few examples of this. Don't just like, not comfortable with it. You have another method. Just know that method. Why don't you know both methods? Just give it a chance, man, because it is possible to do it. I will try and make factor and remainder theorem videos in the week if I can get a visualizer in a week. Then I will focus on this part very much more, and maybe give you steps on how to do this properly. Maybe it'll be easier for you to understand, so you can maybe utilize both methods to double check answers. But yeah, synthetic division. For now, continue with it, but don't just close your eyes to other methods, man. I would still give this another chance, or give this more chance. But I will sort you out with videos, man. Don't worry. Let's see what the textbook is saying. Can we carry on, guys?
Just one last question. Can sir maybe also add a video about the calculator?
Okay, let me make a note on these things. Let's make a note.
Thank you.
Okay. So it is factor main theorem, and then number 2 is calculator.
So just to get my calculator back to where it was, I have to press mode and comp, right?
No. To get it back to, okay. Very important question also that you're bringing up now. So, what I suggest for you to learn as a practice, right? So, like this now, my calculator I'm gonna say it's stuck in this mode. I wanna say 1 plus 1, but I can't because it's gonna jump around like this. How do I get it back? To reset your calculator, you say shift 9, then you say all number 3, equal again. Now it's clear. Now I can carry on with 1 plus 1. It's 2. Hyena, who knew that? Yeah. So always do this, because I found that even with myself back in the day, when I would type in something, I would get a different answer. Even though I type it 3 times, I get different answer. So clear, always do that. Always clear your calculator, because it could be in a mode by anything, by accident, man. You press by accident, it's in a wrong mode, you get wrong numbers. Everything you do in that paper, incorrect. Before papers,
Okay, thanks very much.
yeah, before you write, before you do homework, before anything, just do it as a practice, just to set it in you. Because I've seen many people that lose marks, fail papers because of a calculator. Okay, let's carry on. So this next one is also a factor in the remainder theorem. So we are given 2m, okay, f of x, my cookie is dying, 2mx squared plus x squared minus x plus 2. Then the question is still saying, let me put this in. This equation is divided by a factor that they give us, x minus 2. There's a remainder of 5, and our mission, our goal, is to find the value of m. So our factor is x minus 2. Our factor is x minus 2, and our x value is 2. basically you say x minus 2 equal to 0, then you bring the 2 over to get your x value. So we have our x value. So we put our x value into the equation 2m2 squared plus 2 squared minus 2 plus 2. Okay. Very much still simple. Now all we do is, with the remainder of 5. Can't forget that one. Definitely can't forget that. Yeah. Okay. And then we must get m. This is very simple. This. If you get this, you're very lucky. Then you're very lucky. So this 2 plus that 2 cancels. Here's a 4. So that is 4. This is 4. This is a 4. 2 squared is 4. 4 times 2 is 8. Okay, that is 8m. 8m plus 5. But then we're gonna say this 4 goes over. That is a 1. 8m. M equals 1 over 8. 1 over 8 like this. Very simple. Very, very simple. This is very good one. Very, if you get this, you're lucky. Because all you're doing is you're substituting and then you are simplifying. Very much straightforward. If you get this over the other one, the previous one, are you very lucky? Can we move on?
No, sir. That's what it is.
Okay.
Thank you.
Before you continue, my mic didn't want to open. I just wanted to ask, is there a way maybe where you can prove if your answer is correct?
Yes. Yes, there is.
Demonstration to us.
So, how to check this, right? Very easy to check it because we are given the answer, and the answer is 5. So, if you put our value of m, it's 1 over 8, right? If you put 1 over 8 within this, substitute m with 1 over 8 and put this whole equation in a calculator, you will get that 5. If you don't get that 5, something is wrong here. Something is wrong. We also do it 2 times 1 over 8 times 2 squared minus 2 plus 2. Now there I get my 5. See, there's my 2 times 1 over 8, 1 over 8, 2 squared plus 2 squared minus 2 plus 2 equals 5. That's how you check. That's why this is a good question to ask. When you see this, you must know 3 marks. Because I'm just putting in what they give me. Okay. Next one is logs. Logarithm. Logarithms. I need more people. Okay. Logarithm. This is question 2. So, question is saying log 2x minus 30 log x2. Ben is dying again. Minus 2 equals to. Okay. Yeah.
Sorry, sir.
Yes.
Is there a certain question paper you're working on, or are you working out of the book?
This is from the tutorial in the math group.
Okay, I was working today because now I'm so lost because I'm looking in the book and I'm seeing what you're doing now. So
look in the math group.
Okay.
Look in the math group. The questions are there.
Okay.
Okay.
Thank you much, sir.
Okay. So, okay. Who here has not worked through the log video or any log video yet?
Me, sir, I have no time. I haven't went through it.
Okay.
I also haven't done it yet.
Okay. So, okay, let me ask this now. Who here has worked through that tutorial that was sent? Or tried a few questions? How far did we get? Did anyone complete it?
Not me, sir. I have 3 subjects that I'm busy working for, sir, and I have been quite difficult. You know, next week we are doing first test, electrical theory, which is quite with work and challenging balancing which one first, which one second. So yeah, it's not that easy. So I won't lie to that. Yeah, I didn't went through. I read as fast and get focused on what that is first in the head, and yeah, so that's what I've been happening.
Okay. So okay. Then I will do this. Let me give me 1 second. What they have to do now is basically teach you the laws of logs, because logs has laws and you can't just do logs, because when you see a log question you won't understand what's happening. It'll be pointless me carrying on with the sum if you don't know the laws that exist for this. Okay. So log laws. I did make and I did send a log video. So take time, go through that, because it is there from the beginning, from scratch. Okay, so first law. This one we will use a log. So we get a log. We have a log, a base, and a number equal to an exponent. So B is the base, N is the number, and K is the exponent. So in logs we have this rule where we say the base drops, the K, the exponent, comes over, becomes an exponent there, and the number goes to the other side. That's all it is. That's all there is. Number two is saying when we have a log and the base is the same as the number, it will equal 1. So this can be anything. If it's log x and x, it will equal 1. No matter what it is, if it's log 1000 and 1000, it will equal 1. If it's log infinity and beyond and infinity beyond there, it will equal 1, no matter what it is. So number 3 is saying anything that is log base to the number 1 equals 0. No matter what you get, it will always be like this. Number 4 is saying we're gonna get a log b and a number. Let me do it like this rather. If we get log number there and a base there, to get that base by that number and that number by this base, we write it as 1 over log base and a number. These laws will mean nothing to you right now, but the moment you're in a situation or a question, you will understand why it's needed, or the rule or the law actually. So when we have log base and a number, and we need to split them up, what we do is we say log the number over log the base, and then the base, now we choose this actually. It's a C for a reason. We choose whatever the base will be according to whatever is in this, whatever the base is, whatever the number is, we choose. And you will see, watch me an example of it. Number 6. Number 6 is saying log b n plus log bc equals to log b n times c. So what this is saying, because that base is the same as this base, and it's a multiplication and it's an addition sign here, I mean there's an addition sign, we put log the base, and then we multiply whatever this number is, we multiply them together because here's an addition. So addition goes with multiplication. Automatically, select a word, automatically, ne? Log bn minus log b c equals log base n over c. It's just the inverse of number 6, of law number 6. Subtraction goes with division. Very straightforward, very simple, and you will get this question. You will most likely see it again. Without a doubt, you will see it. Then we have another one. It is saying log base n to the power of a number. That exponent we can write, or we can, the exponent we can bring to the front and multiply. So it's going to be c times log base n equal k. That's how it's the laws, and right now the laws will mean nothing to you. But you need to look at that video, because in that video there's a few examples that will open your eyes to these laws. Okay. So this one here now. We have log 2x minus 3 log x 2. We never want a x value, because the question is solve x, right? And we never want x in the base form. So what law are we going to use to get that x out there? I know what I would use. There's many different ones to use, but I know what I'm going to use, because I know it's the simplest one. Does anyone have a suggestion?
Can you use number 4?
Yes. Number 4, 100% the easiest one, simplest one, the least writing needed. But you can use number 5. Definitely you can use number 5. Number 5, you will just write like so much. But let's do number 4. Number 4, nice and easy. Mathematics is saying, even if you use number 5 will give you the exact same answer. But let's do it. So, my cookies keep dying. Okay. Let me just put my cookies nice. Log 2x minus 3 over log 2x equal to, you see, log n b, there's actually, let's say there's actually a 1 in front, right? So, but we have a 3 there, so it's 1 log x to 2. Then the inverse to swap the base and the number around is 1, this number, that number, over log, now the inverse 2x. That's simple. That's how you apply the law. Very straightforward. But you must know that the law exists. You know how to use it, when you can use it, when you're supposed to use it. Okay. So what do we do now? The best thing to do now is multiply, because we don't want a fraction. It's going to complicate things. So what I'm going to do is I'm going to multiply this whole equation, the whole thing, with log 2x. And then I'm going to get, what is log 2x times log 2x? Does anybody know? Anybody?
Is it log 2x squared?
Yes. Correct. I put it in brackets like that. So log 2x times this fraction, 3 over log 2x, is what? According to maths, the log 2x will cancel each other. You're left with a 3. Then here, 2 times log 2x is log 2x, like that, equal. So, what can you notice about this? I know what I see. I see this x squared plus a number plus a bx. Basically, your trinomial. So, remember I said that there will be a few instances or or questions where you will use the K method. This is one of them, because we're going to factorize this, but to make it easier, we're going to use the K method. So let K equal log 2x. Now please listen carefully now. This becomes K squared minus 2K minus 3. Okay, you can say, yeah, equal to 0. So to factorize this, we have a K there, we have a K there. It's a 3 and a 1, negative and positive. So K equals negative 1 and K equals positive 3. So if K is equal to log 2x, so then that means negative 1 equals log 2x and 3 equals log 2x, like that. How do we simplify from here? Using the rules. Can anyone see? Can anyone tell me? What rule am I going to use to get the value of x?
Rule 2, I think.
Rule 2.
Rule 2.
Why?
It looks the same.
How? Rule 2 is saying log base and the number is the same, equal to 1.
Oh, it's the same.
But here we have log 2x equal to negative 1 and log 2x equal to negative 3 or equal to 3. How am I going to get the value of x from here?
Rule 1.
Yes. Rule 1 is the only one that will work here. And you will use that one the most out of all of them. So, what does it say? So, the base, it drops. The number on this side becomes the exponent. And then the number here goes to the other side. And you can simplify this. 2 to the power 3 is 8. Here again, the base 2 drops, the exponent becomes the exponent there. The number goes to the other side. Again, we can simplify. 2 to the power 1 is 1 over 2. Knowing the rules, insanely important. Very important.
Sorry, sir.
Yes.
Yeah, then by the second rule, you said times log 2x, huh? So you multiply the whole line by log 2x.
Yes. So let us do it like that. So yeah, there we multiply. There we multiply. And then there we multiply. This is one of many different ways they can ask a log question. One of many.
How many marks will this question be, sir?
This one, so let me check. This one, this is 4 marks. You see, it's just this part. It's just this part. 4 or 5 marks maybe. 5 is a lot.
So I just want to find out where you put where you said yeah, let k equal to log x. How did you get your -2 and the -3? Oh, sorry. K squared minus. Okay, never mind. Figured it out.
Okay, cool. Yeah, let me, yes. Now let me use, also your best friend, I don't know if everyone knows about the TVET apps to get question papers from. On that apps, the memo is there. So you can answer math questions to your heart's content. You can have all the fun in the world with the math questions. It is there. You can download the app. Any paper from many years ago, even. So there's countless papers that are there. You can get all the practice in. All the practice. But I understand if you don't know like the rules or the laws, you'll be wasting your time. So log videos, they are in a group already. I will resend them after we're done here. But please take some time to go through them. There is 4 chapters, right? That you must know for your test 1. For me, you can take 1 hour if you can. It's a lot, 1 hour. Just go to the basics. Basics, two or three, 4, 5 examples. Like maybe one day you focus on chapter 1, next day chapter 2, chapter 3, chapter 4. Friday come, you can do a whole question paper. Again, the tutorial, you will fly through it. Look at question papers for benefit you. Math is one thing. If you don't practice, you will suffer. Can we carry on? What I'm gonna do is gonna keep that open so we can use it. Okay, next one. 2 log x 4 minus log x 1/2 equals okay. Okay, one thing I didn't mention perhaps with this rule number 8 is, you see here's an exponent, right? We can bring this back from this form. We can bring this back to this form. So what does that mean? That means that we can take this c and move it back to the exponent if we choose to do that, and it's what we need in the moment, we can do it. That's mathematics, like you are allowed to. Like, yeah, we need to do that. Yeah, we definitely have to use that to bring that to back to that form. We can do that. So let's quickly do that. Log x4 squared, number 4 squared, minus log x. I don't like working with a fraction like this, so I'm gonna say 2 to the power negative 1 equal to 3 minus log x 54. Okay, now you must have an I for these things, and what I want you to notice is the base. The base, right, is the same throughout the whole equation. It's the same. So when you see that, you must know we're gonna use these ones. Number 7 and number 6 we're gonna use. But to make it easier, let's bring everything to one side. Okay, let's bring everything to one side. That's a log. So we're gonna have log x4 squared minus log x to the power minus 1 plus log x 54 equal to 3. So we're gonna write down log of x. We're gonna write down log of x. So log x. So what you must now know is anything my bad guys, forgetting that thing. Almost there, we're halfway. We more than halfway. And you just wait a few minutes for the rest to join, a few others. Is everybody okay so far? Those who are joining again, is everyone okay so far?
Yes, so you just have to put on your
yes.
video.
Oh, yeah, thanks for reminding me. I would have continued. Okay, we are back. Does anybody know how to write this from here? Does anybody know?
Would it not be? That's going to be number there.
I'll give you.
4.
Okay.
Okay, 4 to the power of 2 minus 2 to the power of, well, over 2 to the power of 1 plus the 54.
You were off correct there.
So can I help you?
Yes.
I think we can open the bracket. Then we say 4 squared divided by 2 to the power of minus 1
Yes.
times 54. Then we close the bracket. Am I on the right path?
You're on the ball 100%. Yes. So, what you must remember is, yeah, we know that's a positive there. Okay. There's a positive. There's a negative. Positive goes with multiplication. So according to the rules, right? According to the rules, multiplication here. See, because it's n times c, because here's a positive, here's a plus. So addition goes with multiplication. Subtraction here goes with division. They go hand in hand always. So if you get a thing like this, it is still the same. This 4 squared is positive, so it goes to the top of the fraction. This 2 minus 1 is a negative log, so it goes under. This positive 54 is a positive log, so it's multiplied like that.
Okay.
Yes. Then equal to 3. So now we need to get x alone. How do we do that? It's the same thing we did earlier. We're going to use what law? Do we know? We should know. It is law number 1. So the base, it drops. This number 3 becomes the exponent. This whole fraction, we could have simplified it, but let's not do that yet. Let's do it this side. Times 54 equals, in the calculator,
Hi, Sally.
can we mute please? Yeah, thank you. 1728 in the calculator. Yeah, x3. Now to simplify this, all we need to do is doing the cube root. Does people know that? I hope everybody knows that you must do the cube root to get rid of that 3 there. You can't just say x equal that and you finish. No, you can't. So x, then cube root of that, I think it's 12, 17, 28 is cube root is that one. Yes, 12. That's your final answer. Not a bad question exactly. Good practice, good practice. Also, there's actually another law that says, number 9. Eh? So, if we get us something like, let's say it's 2 log 4, ne? This is equal to log 2 log 10 4. So, if you're ever given a log like this with no base, there's no base over there, you must know that that base, it is equal to 10 no matter what is given. If there's no base given, the base is 10. I think the video that I made includes that somewhere in there. There's no base given, the base is 10. Can we move on?
Just one quick question.
Yes.
So that x to the power of 3. So your root depends on that, on whatever number is
Yes.
there x.
Yes, sir. So
If that was a 2, it would have been square root of 2.
yes. If it was a 5, it would be square root of 5. If it was a 10, square root of 10. On both sides, ne? Both sides.
Yeah, I was just a bit confused there with that one.
Okay.
Thanks.
No problem. Logs, guys, it's made to be scary and difficult, but this one and practice with examples as many as you can with different variety. Logs will be easy. Just practice. It has to be practiced. Otherwise, you can't go into a test with doing logs 2-3 times. Like ever. Practice many examples as possible. Many. I think what I will do is I will send maybe questions randomly just for practice of the work we did now so far that we're gonna cover. And then for those that want to do extra, I will send it. And then if you do it, you can send in the group. I will just say, there's a mistake there, there's a mistake here, but I will send it. Then I will check that personally. Can we carry on? Sorry for those now that's joining now only. So I quickly explain to you there, Ms. Boltman. Are you okay here? I will also upload this video. I hope everyone could be able to hear me. Yeah, the sound is a problem. So if the sound is a problem, just bear with me. But yeah, the sound is a problem with this machine. Let us move. Let us move. This next one is called thirds. Thirds and equations. You want new cookies? Okay. Well, 1 is saying 10 minus 3x minus x minus 2. Okay. Now you see, right? The video that I sent on this work explains exactly the steps. I put steps in there. I wrote down the steps you need to solve equations like this. So that video is it's great, man. It's great because I write down steps like 1 to 6, 1 to 5 for doing this. So when you get this, first thing you do is you put that x on the side. So x minus 2, 10 minus 3x. What do we do now? We don't want square root. So what do? We square both sides. we square that side, and we square that side. So when you square a square root, the square root falls away, and then you're left with just what is inside. This will become x minus 2, x minus 2. Now we have to expand this, and we say x times x is x squared. X times 2 is minus 2x. Minus 2 times x is minus 2x. Minus 2 times minus 2 is a positive 4. That's equal x squared minus 4x plus 4. This is still 10 minus 3x, 10 minus 3x. All we do now is we simplify this. And we keep it this side, so x squared is this minus 3x come over here. We're going to be left with like minus x. Positive 10 come over this side, we left with minus 6. Now we have to factorize. So we can have a 3 and a 2, a negative 3 and a positive 2. So x equals to negative positive 3 and x equals minus 2. So very straightforward sometimes. What we have to do now is we have to test that the answers we're getting is actually correct, because here we are given the answer, right? We are given the answer. And now we have to test. We have to test, and how we test is very simple. We substitute this x1 value in here. So 10 minus 3 times 3 minus 3 equals. And then for this over here, the second one, we say 10 minus 3 minus 2 minus 2. In the calculator, we just put this 10 minus 3 times 3 minus 3 is negative 2. That means that this is correct, because we have that negative 2 there. Now times minus 2 is 6. This is incorrect, because it's not the number we have. That means, therefore, x equal to 3 only. Only x equal 3 will work. You can't just leave your answer like so. You have to test, see which one will work best, or actually works. And that's this one, yeah. Are we okay here? Next one. So 16 plus 2 equal. So what do? We square both sides. Square. When you square root, the square root falls away. Whatever is left, it's left over there. So when you expand this, we're gonna get 3 to the power 2x plus 4 to the power 3x plus 4. All we do now is we move things over, and we keep this one. So we're gonna have 16 plus 3 2x minus 3 2x minus 4. So that will cancel with that one. 4 minus 16 is 12. 4x. Divide by 4 here, you're left with 3x. Divide with 4 over here, you're left with 3. So, laws of exponents. If you don't know laws of exponents, go look at that video that I sent. This is 3 to the power 1. So, when our bases are the same, we can set the exponents equal to each other. That means x equals to 1. Finishing klaar. That's the story over. That's straightforward. This it's repeated a few times.
Sorry, sir.
Yes.
4 is 4 times 3.
Yes.
4 times 3, 12.
No.
12 there.
No.
Sorry.
No, you see, it's not 4 times 3, it's 12. Yeah? Because this 3 to the power of x, that 3 to the power of x, this one, that one, this one, that one. They are all on their own. It's almost like, it's like saying 4x squared. 4x squared is the same as saying 4 times x squared. They are not together exactly, even though they're not one thing. They are two things together. Yeah. So you can't say 4 times 3 is 12 to the power of x. No. They say that is incorrect because that 3 to the power of x is his own thing. It's his own thing. It has nothing to do with that 4. That 4 is just saying there is 4 of this 3 times x that you got from expanding this here. You got 4.
sir, can I just ask, like, how did you get obviously when you expanded the 3x plus 2 to the power of 2, like, how did you get the 3, 2 to x?
So, your laws of exponent is saying when you multiply exponents with the same base, you can add the exponent. This is why you need to know your laws of exponents. So when you multiply 3x, 3 to the power of x with 3 to the power of x, you add these exponents to make it 2x. When you multiply 3x with 2, you get 2 times 3x. Can we mute there, please, guys? Thank you. Then, when you multiply this 2 with that 3, you get 2 3x. This 2 with that 2, you just get a 4. When you simplify this, you get 3 2x. When you add these, you get 4 3x plus 4. Does it make sense?
Okay, yeah, that makes sense now. If you can just read that quickly so I can write it down.
Yes.
Sir,
Yes.
is the fourth week on marks out of 75?
No, 4th week is never that big. 35.
Oh.
35 is your
Okay.
number. 35.
Okay. I'm just checking.
Okay.
So this is 8-week question papers working through.
No, this is for your test 1. 4th week.
For test 1.
Yes.
Okay. Thank you, sir.
Okay. What I want you guys to know is mathematics. I know everyone makes it to be scary. Even I saw it as, a problem back in the day, a few years ago. But practice, and like you must make an intent. You must want to learn the maths, man. You must want to learn it, and then once you start enjoying solving the problems, understanding the rules and everything, maths will become a breeze. It'll become a breeze. And I know maybe the work seems like a lot, but this isn't a lot. Let me tell you, this isn't a lot. If you can push yourself with speed and but you understand what you're doing and you practice enough, you will do very, very well.
Just one quick question, please, man.
Yes.
Were you wrote green the 2 times 3x?
Yes.
Wouldn't it have been easier to write it as 3x times 2? Because in the sum itself, you need to divide that 12 by 4. So usually when the 4 is like that on its own, when you take it over, you minus. You understand what I'm trying to say?
Say it again.
I think it's where you see that 4's actually times to the 3x. So if you have to take a times and move it over, it becomes a divide.
No. Oh, yes, like that, yes. See, no, you're not taking over the 4. You are getting rid of it by dividing. Don't say take over, ne? Because, only the sign of positive and negative changes when you take it to the other side of the equal sign. When you multiply and divide, you either multiply to get away a fraction, or you divide to get away a number that's next to the coefficient that you want to keep. Like here, we divided with a 4 on that side.
Yeah, but that's why I'm when the way I'm looking at it, it would have been easy if it was 3x times 4, and then we know, okay, we need to divide it on the other side.
Okay, now you see the great thing about mathematics, right? You saying that you want to put as that, né? You are saying that
That's correct, yeah.
it's the exact same thing. You can do it. It's the exact same thing. Won't be a problem if you understand that better and it makes sense mathematically. You can do it because this is math. It's the same thing.
Thank you.
No problem. Okay. Next one. So when we get this, we don't want to work with a fraction. We never want to work with a fraction. So we bring that up like that. So a hint to help you to simplify that 81. The hint is here, what you have there. You know that your base is a 3 on this side. That means that on this side, you have to have a base 3 to the power of something. So 3 to the power of 4 is 81. If you don't know, I think what you can do, yeah, don't know if you saw that, né? So you put 81 in your calculator. I wonder if I can do it with that one. You put 81 to the power negative 1 in your calculator, you press equal, you see that's 1 over 81. Exact same thing, that's mathematics. The same number, same value. You press shift and factorize, okay, you can't do it like that. So just 81. Shift. You see it's a fact that's there. Then you can see the fact. That's factorized. You can factorize a number. Only certain numbers you can do this with. Like if it's maybe if you can factorize, you will get the answer like this. 3 to the power 4. So it is 3 to the power 4 is 81. But it's a negative, so we must remember to put that negative there. So in mathematics, né, this is all the same number. It's all the same value. So 3 2x minus 1. So if you remember what I said, in mathematics, when your bases are the same and equal to each other, meaning there's no extra things in between, there's no plus 1 here or anything, they are not equal to each other, you can set the exponents equal to each other as well. So 2x minus 1 or minus 4. Then all we do is we take that negative 1 over, it will become, to leave us with a minus 3 there, 2x, x equal, divided the 2, now we divide to get the 2 away, x equal minus 3 over 2. Very simple, very straightforward. Very important to know your rules, what your rules say. when your bases are the same, you can set the exponents equal to each other. Go watch my videos. In there, they say everything you need to know for these equations. Laws of exponents, laws of your logs, log laws. Very important, very, very important. Let me do the other one next to it. Okay. So 9 to the power 2x equals to 27. 2x minus 3. Is it a 3 now? Oh, my bad, my bad. uh, Let me just look at the question. I don't have the question now. It is saying, oh, it's a 2. That is 2. Okay. So, what do we do now? What do we do now?
So, I think we can put the 9 to the power of 3.
9 to the power of 3.
Yes. And then we can do the same with the base of 27. The 3 to the power of 3 is also 27.
yeah, you know, I see what you are saying, but you're saying it incorrectly. You must make the 3, the 9, 3 to the power of 2.
Yeah, to the power of 2, sorry. Yeah.
Yes,
I
yeah.
was thinking it, sorry.
Okay, then 2x. 3
3
to
to
the
the
power
power
of
of 3.
3,
Yes.
2x
2
minus 2. Can you say why you chose that 3?
to make the bases the same.
Yes.
So,
So,
when the bases is the same, the exponents drop.
yes.
We could also use a 9. We'll keep that 9 there.
Why do you say that? If you leave that 9 to the power of 2, you have to put this also 9 to the power of something. And 9 to the power of anything will never give you 27. Never.
Yeah, my bad. I got it down.
Yes. So when you do this, you have to make sure that both sides you can use the same number as the base. You have to make sure. If you can't, rather look more, but it's going to be clear. It's normally very, very clear. Maybe it's to the power 2 something, to the power 4 something, but you have to know that both sides will be the same. But let's first simplify the brackets before we set them equal to each other. So this is 4x. This is 3 times 2 is 6x. 3 times 2 is minus 6. Equals. Now the bases are the same. We can set up the exponents equal to each other. So 4x comes this side, leaves us with 2x. And then this negative 6 goes over, leave with a 6. And then 2x divided by 2 is an x. 2 and 6 divided by 2 is a 3. X equal to 3. Very straightforward. Very, very simple. Lots of exponents. If you didn't know the law of exponents to do this, you'll never get your answer. No matter how hard you look at that, you'll never know. I don't think we're gonna make it for the paper finish now by 7 o'clock. So what do you guys want? Do you want to finish the paper today, tonight still? Or, yeah, tomorrow might be a problem. Let us see. Okay, let me ask this. Let me ask this. Has anyone worked on completing the square? Anyone?
Come again, sir?
Has anyone worked with completing the square?
Can you maybe do one example to see?
What I can do is I can show you what it looks like. So completing the square is it's factorizing basically. It's you solving x, not factorizing really. It's using like that big quadratic formula. It's that, but manual, where you put in the calculator with that quadratic formula that x equals minus b plus minus b squared square root b squared minus 4ac over 2a. It's this basically. This video of this work, it's
Yes, I did. Yes, sir.
it's in that work. It's
Yes,
in
sir.
yeah.
Yes, I did that one.
Okay, cool.
I did. Yeah. I did that. B minus plus 4ac over 2ac. I did that one.
Yes. I hear what you are saying, but completing the square is the manual. You're doing it out manually. That formula, you would use your calculator. You would put all those things inside here. You would type it all in here. Press equal, you get your answer. But here you must do it manually. I feel like, okay. I will do the examples finished that we have now in the question paper. Yeah, this is quick. Okay. Shall we move? Okay. We are given 4x minus 48 equals to 48 minus 2x squared. Two is minus 18 minus x squared 9x. So when we do this, let me let's get new cookies. So when you do this, you want your x, anything with the x must be left hand side or on one side. And I'm going to bring it on that side because I don't want a negative and I don't want a value in front here. So I'm going to have positive 2x squared plus 4x equals to 48. Okay, so I don't want a 2 there. So what do I have to do to get rid of that 2? Divide with 2 to the whole equation. So divide with 2. Divide with 2, I'm left with x squared plus 2x equals 24. Divide with 2 throughout the whole equation. Okay, what do I do now? So what I do now is I see my b value. 1 second. Okay. So I write this x squared plus 2x plus 2 times 1 over 2, 24 squared and the squared. Okay.
So can I ask why you do that?
So my b, so we know the formula ax squared plus bx plus c. This is my c value. It's actually this one here. Ax squared plus bx, and that's my c value. So your b value, you multiply with half, then you square that bracket. So my b value, I multiply with a half, and then I square this bracket. And I do it on both sides. And you're adding this, right? You're adding. Always you're gonna add it. Always you're gonna add it. This is part of the method. So you take the b.
So you obviously when you take your b, then it's always times a half.
Yes, always times a half. Whatever your b value is, it can be a 3 over 2, a 7 over 2, a 8 over 3. It will times half, and you square that bracket always. Okay. Then 2 times half is 1. 1 squared is 1. Yo, I must get a new cookie. So 1. So this is x squared plus 2x plus 1 equals 24 plus 1. So what you're gonna do now is let's just 25, simplify that. So what you do now is you're gonna factorize this, but using this method. You're gonna square that one. You're gonna square that one. Then whatever sign is there, you're gonna bring it down. So square root of x squared is x. You bring the sign down. Whatever it is, if it's negative, you put a negative there. If it's positive there, you put a positive there. Always. That one you bring down, it's a 1. Then you square that. Then you're still not done yet because you need a value for x. And to do that, you must square root both sides now, both sides, because you need this x value. To get rid of a square, you square root. So x plus 1 equals 25 equals x plus 1. The squared falls away and you're left with just the x plus 1. When you square root a whole number, your answer is 5. But a plus minus, there's two answers. So, because there's two answers, we have two x values. x1 is same. When we bring this one over, so we're going to use positive 5 here, and then here we're going to have negative 5. So that 1 will go over to become a negative 1. So 5 minus 1 is a 4. Negative 5 minus negative 1, negative 6. This is your answer. This is your answer.
Excuse me, sir.
Yes.
If I use the other formula about minus b plus over b squared plus 4 ac, I'm not going to get the same answer.
You will get exactly the same answer.
Because I tried, because there was one video that was in the group either and by the beginning when we started the group chat, and I went through with that option of mine, which I got the different answer for what was in the video.
That means that either you put a wrong sign, or in the video there was a wrong sign.
Yeah, because I even mentioned it, but there was no one that responded to me. I was like, because I tried, even went to Google to find out if my answer was correct, and then Google was showing me that my answer was correct, but I was still getting the other different answer was the one that was about the video.
Yeah, I hear you. Maybe there's a sign that was incorrect in the video.
I hope so, because I was really quite doubting what they should have done. You know, I was not really sure what's going on anymore.
Yeah. Okay. Let us see about that one. Let us see the next one.
Can we then try it again? Can we then try on this one here to see if we're going to get the same answer?
Yes. Let's do it after this one.
Okay, sir.
Okay. So, next one. Exactly the same steps we did here. We're gonna do here. Exactly the same steps. Nothing special. Nothing different. So, let's put the x squared there, minus, and then here the 9x. 18. We don't want the minus, we don't want the number in front here. So multiply with a negative throughout the whole equation. So we're gonna have x squared plus 9x equals negative 18. So we say x squared plus 9x plus, in brackets, 9 times half squared equals negative 18 plus 9 times half squared. Your b value times half, in brackets, squared. You add it on this side and you add on this side. So 9 times half, yeah, it's 4.5. Let's just do this in the calculator. 9 times half squared is 81 over 4. X squared plus 9x plus. Yes, 81 over 4. Okay. So, okay, let us simplify this on the side first. So negative 18 plus 81 over 4. It's a 9 over 4. So what do we do now? We need to simplify this one here. We need to simplify this here, right? So what did we do here? We square root this one. We square root this one. We bring down this sign. We bring it down. So square root x squared is a x. The sign we bring down is a positive. Square root of 81 is a 9. Square root of 4 is a 2. And then this is in brackets squared. Now, what we do is we square root both sides. And then we're going to be left with a plus minus. Because whenever you square root a whole number, you're left with a plus or minus. So square root of 9 is a 3, square root of 4 is a 2. Then here we're left with x plus 9 over 2. Again, we have 2. Let us do it like this. X equals plus minus 3 over 2 minus 9 over 2. Therefore, x1 equals positive 3 over 2 minus 9 over 2 equal x2 equals negative 3 over 2 minus 9 over 2 equal. Calculator. Negative 3. Negative 3 for this one. Negative 6 for this one. This is your answer. Exactly the same steps. Nothing special. But look at the video that I sent on completing the square, because it's very important. This one, like you said now, sir, ne? One of the sirs now said, they said they used minus b plus
minus b plus minus over b squared minus 4a c over 2a. There's that one.
Yes. If you use this one, you will get the exact same answers.
So that means the video was wrong then.
But if you use this one, you will get no marks. No marks you will get if you use this. You can use this one to check your answer, yes. But if you use this, when they say complete the square, you will get no marks.
I see.
Yes.
Yeah, because they're different. Yeah.
Yes. You just use to check. Nothing else.
Okay. Thank you, sir.
Okay. Can we move on, guys?
Yes, sir.
Okay. This next one is a word sum. I do have a word sum video. Yeah, okay. I'm gonna write quickly this thing there. So perimeter of a triangle is 40 meters. determine the length of the hypotenuse and the area of the triangle if the length of one of the other two sides, okay, if one of the lengths of the two other sides is 8 meters. Okay, that's what we have. But they might pick me off again, so we must just join again, guys. You must know the drill by now. Okay. So we have a triangle. We have a triangle. Let's draw a triangle. Triangle, the perimeter. Perimeter is 40 meters. Determine the length of the hypotenuse. So we need to get this one. The area of the triangle. We must determine the length of the hypotenuse and the area. The area of a triangle, we must know. The area of a triangle is half the breadth times the height. Give everyone a chance to join again. Can we mute again, please, guys?
The live streams.
Okay, I think we can continue. Let's just mark this nice. Okay. We need to get the length of our hypotenuse, and they say one length of the two other sides is 8 meters. So 8 meters. Okay. So if let's say, okay, the hypotenuse is it's our length, it's one length. AB is 8 meters. BC, let's mark this. Okay, I'm writing wrong now. Writing wrong. AB equals L, our hypotenuse, and then AC equals 8 meters. Oh, 8 meters there. That means that BC, who knows what BC is equal to? Does anybody know? we're given a perimeter, right? So 40 minus that 8 is 32 minus this length. So it's 32 minus the length. It's unknown still, so we must still get it. Okay. We can use Pythagoras to get the hypotenuse. We can use Pythagoras to get the hypotenuse. So Pythagoras, this guy is very famous. So AB squared equals to BC squared, which is 32 minus L plus AC squared. Now all we do is we substitute in what our values. So AB is L squared equals to BC, which is 32 minus L squared plus AC, that is 8 squared. So 8 squared is 64, that's L squared. 32 squared is 100, not 100, 1024 minus L squared. Nope, I'm making a mistake here. 32 minus L. Yeah. 32 times 32 is 1024. 32 times L minus L is going to be minus 64L. Let's just follow it. So 32 times negative L is negative 32L. Negative L times negative times 32 is together. That is negative 64L. That's just times in out brackets. So that was another space. So plus L squared plus 64. So 1024. Okay, now we must simplify. Okay. Oh, my brain is getting tired now. So this L squared will cancel with that L squared. Then we left with this minus 64L we're gonna take here. So it's 64L there. Then this 64 we're gonna keep there. Then 1024 plus 64 is, that's a 8, that's a 8, that's a 0 and a 1. 64L. Therefore, L equals 64 divided by 10888. So 1088 divided by 64, 17. So L is 17 meters. And it, yeah, equals 17 meters. That means, let me squeeze this in here. Therefore, BC equals to 32 minus 17. That's equal to 15 meters. Word sums is very like, you need to think and you need to draw out and write down everything I've given you. There is a video on this that I did send Go look at that. Go and look at that. So, they asked us to determine the length of the hypotenuse. 17. We got it. We got the other side, even though they didn't ask for it. We got it. What we got to do now is get the area. So, the area of a triangle is half base times its perpendicular height. Sometimes this formula won't be given, so you need to know like a variety, or not a big range, but a decent enough range of formulas and area formulas, volume formulas. Not to now, make your brain explode, but just know a few general ones. Area, volume. It's good to know them. Okay. So is base times the height. So half 15 times 8 equals times 15 times 8, 60 meters. And it's an area, so it's squared. Squared like that. But look at the videos that I sent, because that video is like, it gives you a nice idea of the type of sums that they could ask you.
So sir, will test one always end on a word sum?
It could definitely. Well, your test one is up until word sum, so most likely you would end on that. Also, just a note to make, let's say you are strong in word sums, for example. You can do word sums first, but you must just number it according to the question paper. But you can start with it first and then carry on to the next thing you know best. The next thing you know best, and leave maybe factorizing for last if you're not so good in it. So you don't waste time in thinking of ways to solve that problem. So you can do that, but just write neatly and number it correctly. Might just save you, a couple minutes. Can we continue?
So,
Yes.
can I do a quick question?
Yes.
That's 15. What is that 15?
So this 15, it's BC, right? This is BC.
Yeah.
Can you see 32 minus our length? Our length we got is 17. 32 is the other side. So the question, right? The question is saying, determine the length of the hypotenuse. We know that this is our hypotenuse because it's opposite, the 90. The 90 that's here.
Yeah.
So they also say that 1 of one of the lengths of the two other sides is 8 meters. That means either this one or this one is 8 meters. So doesn't matter which one you choose, it just has to be 8 meters. So I chose AC as 8 meters. I chose AC as 8 meters and AB as the hypotenuse, the length now. So that means that, see, we're given a perimeter as well. We were given a perimeter. So perimeter is saying, perimeter is saying for a triangle, it's saying side 1 plus side 2 plus side 3. And we have, or the length we are asked, and we also were given the 8 meters. But let's do it like this then. Let's do it like this. So perimeter of this one, the perimeter of this one would be, we have AB plus AC plus BC. That's the perimeter. It's still the same thing as this, but this is now for our triangle. So to get BC, we must basically manipulate this formula. So we're gonna put P minus AB minus AC equals to BC. So it is 40 minus L minus that 8 is BC. So 40 minus L, which is our 17, minus 8. So 40 minus 17 minus 8 must give us our 15, right? So let's do it in a calculator. 40 minus 17 minus 8 equals 15. This is 15. BC is 15. You see, ne? That's the thing with word sum. You must know that your perimeter means this. Side 1 plus side 2 plus side 3. You must know that. So you can manipulate the formula like this to give you what you need. Manipulating formulas is very important. We're going to do that next. That's the next question. The subject of the formula.
Okay, so BC isn't actually 32, it's actually 15. But you use 32 just to work out your
Yes, your true value.
Okay.
Yeah, because it's not just 32. It's 32 minus the length. See, this 32, I already minus the 8 from the 40. This 32, it's saying 40 minus 8 minus L. It's the exact same thing.
Okay.
Yeah. Parameter. Yeah. This is the thing about the word sum. You must really think about what is given, what is asked. Really think what you have. It's never this straightforward actually. That's why look at the videos I've sent, I think I made very nice notes for you to like analyze stuff, man. You must analyze properly. Draw on the side. Draw on the side. Write down everything you have, everything you manipulated, everything. Okay. Let us carry on. So the next one is my favorite kind of sums. It's subject of the formula. Subject of the formula. So m equals k h squared plus h squared over b. And they want small h. So we must manipulate this whole equation to give us this the small h. So for these kind of questions, there's always a few ways to do it, but me, I just like starting at any point. This should be your free marks, to be honest with you. Very much your free marks. I'm gonna share a video that has a trick question for this, and it's very good to know. Okay, let's begin. We need the small h. Keep in mind that we need this alone. Absolutely alone, we need it alone. So what we do now is we get rid of this b. So we multiply with b throughout the whole equation, and we left with mb equals k h squared plus h squared divided with k. Divided with k. So mb over k equals h squared plus h squared. I want to get rid of this, so I'm going to bring it this side. So mb over k minus h squared equals h squared. Then this isn't alone yet. It needs to be alone, and to get rid of a square, you square root both sides. So I'm left with mb over k minus h squared. That's the final answer. Does anyone have any questions on that? This is like 3 marks for me personally, I think. Very much of 3 marks. Are we okay there, guys? Straightforward. Okay. Next one. Where is this question now? Yo, I lost it. Okay, yeah. So it's saying d equals and they want b. They want small b. So to get small b, and to get rid of the square root here, you see, even if you flustered with you don't know where to start somewhere. So to get rid of this, square both sides. So this is d squared equals x plus b over x minus b. The only way to work this from here is to multiply with x minus b. So we're gonna have d squared x minus b x plus b. Then we multiply in here d squared x minus d squared b x plus b. Then then we bring this one here and then that x we bring there. So all the x is one side, all the b is one side. Dx minus x d squared b plus b.